Hello, Alex Cole with BobCAD-CAM here. So this video is a continuation of the first video where we covered the UI and the CAD tools. In this video, we're going to do an overview of, in relation to laser plasma water jet machines, how to create toolpaths to cut out this part. So let's go ahead and get started. So on the left docked window here in the left pane, I'm going to go to the CAM tree and make sure that that page is visible. The workflow that we need to do is that we need to create first our actual machining job. So on the CAM defaults item, I will right click and use the new job option from the menu. Now here we're going to select the type of job, and based on your product license you may or may not have all of these jobs available. For laser plasma water jet machines or milling machines, we're going to use a milling job type, and then the machine that we have selected from our list is going to be the default machine that's loaded for that job. Now for laser plasma water jet jobs, it's important to make sure that those machines are selected first before we start creating operations. So I'm going to go ahead and just select a 3-axis plasma machine, one of the defaults. And we have the option of either clicking OK, which will just create the job in the tree, or go into the stock wizard, which is the next step in this process. So when we're creating or programming to cut out this part, what we need to do is we need to create a job. And then the next step will be to define the stock that that job is going to use. And then after that, we'll define the machine setup. And the machine setup tells the system where the 0 is going to be located on our stock, and relative to how you're also going to be setting up the material and where 0 is on your machine. So these are very important steps. Once we've completed those steps, then we can move on to actually creating the toolpaths to machine our part. So after we've created this job, this wizard will simply walk us through this procedure as long as we select the options to do so. So we're going to go ahead and go right into the stock wizard. And the first step in that is to define our workpiece. Now, for these types of jobs, we don't need to worry about selecting a workpiece. So we're just going to click the double arrow to advance to the next page. So now we're on the stock definition, and as you can see, our screen has changed. And what it did is, by default, our system uses the extents of the geometry that's on the screen. If you have wireframe geometry like we do, and that's the only geometry that's in the screen, then it's going to use a bounding box to create a rectangle around your part. Now, if you're going to be working from a sheet of material that is not that size and is, say a standard sheet of material, say 4x8 or 5x10, then we can input the parameters here to facilitate that. So, for example, I can set my X dimension to let's do 24 inches. I'll set the Y dimension to 24 inches as well. And if I zoom out, we can see that it's now created this stock around the part that's 24 by 24. The thickness that we're going to use for this is not going to be 1 inch. I'm going to change this to 0.25 to make it a 1/4 inch thick. Now, the actual center of our stock, right now our part is directly in the center because it's using that automatic bounding location that it picked up when it first started. But I can change the origin either by snapping to a location using the origin option here and then picking a point in the CAD space, or we can manually enter values. So in this particular case, I'm going to set this origin. Let's try X minus, well, let's see. No, we won't be negative here. If we're doing 24, let's set this to, say, 12 in X and 12 in Y, and that puts our corner in the center of our part. And, well, that's not going to work. So let's go ahead and modify that down. Let's take this to 8 and 8. And so now we have our part located kind of in the corner of our stock. So once you have the stock parameters entered to where you're happy with where everything's located, we can click the double arrow to the right to go ahead and advance into the machine setup. So when we advance into the machine setup, and as I rotate this, you'll notice that we actually have all these little points that get drawn on the corners around our part. And the reason for this is we need locations to define where the 0 is going to be for our NC program. And this is going to have to directly correlate with where 0 is going to be set up on your machine tool when you put that sheet of material on the machine. So some of the laser plasma water jet type machines, they always operate off of a fixed 0 location, maybe in the back left corner, back right corner of the machine. It'll be like the home position for that machine. And then other machines have the ability to define work offsets, work piece offsets that define a 0 location anywhere inside the travel of the machine. You're going to have to understand what option your machine supports and then apply that accordingly. So in this particular case, I'm going to act like the back left corner at the bottom of my material is where my 0 is. And we'll go ahead and run with that. So what I'm going to do is in here under the setup orientation, I'm going to go to the coordinate system group and I'm going to click in that origin box. And this is allowing me now to go out to the CAD window and pick a spot to define 0 for my program. So by zooming in and selecting the back bottom corner of my piece, I can now see that I have 0 defined in that back left bottom corner. Okay, so now that that's defined, we can go ahead and continue on. So I will finish the machine setup for right now by just clicking the OK button. So now we have our stock defined, and we can see that in the the CAM tree, the job has been populated. We have our machine, we have our stock item is added, and we have our machine setup. Now by clicking on the machine setup, we will have a gnomon get presented in the CAD space to show us where that 0 location for our program is located. So now we can go ahead and start looking at creating a feature for cutting our part. But before we start that, I want to go ahead and show you, because the stock is shown on the screen, sometimes that can be a distraction when trying to work in the system. You have the ability to turn that visibility on and off for that item. So the stock item in the tree, I want to right click on that, and I'm going to use the blank unblank option to go ahead and hide that stock. Now, anytime that you click on the stock item when it has been hidden, it will show that stock item. But whenever you click on a different item in the CAM tree, then it will go back to its blanked or hidden state. All right, so next up, let's go ahead and create our first machining feature. Okay, so to get started with programming on this part, what we're going to want to do is right-click on the machine setup. And this drop-down menu is going to contain the available machining features that we can choose from. Now, the type of cut that we want to do around this part is just going to be a profile cut around the outside. So I'm just going to go to the mill 2-axis feature. So by clicking that, it's going to launch the feature wizard for the mill 2-axis, and the first page that we're going to be presented with is for geometry selection. So think of the feature as an item that's tied to the geometry, and the operations are the machining operations that are going to be created on that geometry. So what we have here is the feature wizard, and on the left-hand side, I guess to give a description here of this page, on the left-hand side we have a tree view of everything that this wizard will walk us through. Now we can either click on one of the items in the tree to go directly to that page, or we can advance through this wizard using the next and previous buttons that are found down here at the bottom. So the first thing we do before we continue on is we're going to want to select our geometry. So I'm going to click the Select Geometry button, and that's going to take us back to the CAD workspace, where I'm going to zoom in a little bit, and then I can select my geometry. Now, if I just wanted to manually pick a couple of these entities that we see out here, not missing the little fillets that are in there, I can manually select a couple of entities, and we can see in the selected geometry box it's going to populate with the individual entities that I have selected. And if those entities are continuous, meaning they're all connected to one another, then we will end up with a single chain under the Profile Chains field. If I select another piece of geometry, for example, if I pick this line here on the other side, we can see that it is selected it, it's added it to the selected geometry, but we now have a second chain. The reason for that second chain is because the system is not able to link those two sets of selected geometry directly. So what this means is that the toolpath will have to make a cut, and then it will have to retract over and then make a separate cut for that other piece. So that's just a little bit about when you're picking the geometry. Now I actually don't want to separate this. I want to select the entire thing. So looking at another way we could do that, I'm going to clear the geometry that's picked by clicking the Delete All option next to it. And this time I'm just going to sketch a window, or drag a selection window by clicking and dragging over all the geometry, and that's going to pick everything. So we can see that we have a preview here, and all of the entities have been highlighted, and we have a preview at depth showing what's been selected. And in the profile chains, we can see that we have one chain listed. So this is an indicator to me that my geometry is closed and there's not any bad locations in that geometry, and that the system was able to complete that all the way around as a closed chain, as a single chain, and not, additional segments and so on. Now the depth that it's showing in this preview is controlled by this total depth field. So we have our top of feature and we have our total depth. So right now the system defaults to 1/2 inch, so 0.5. But we set this geometry up, our stock, if you recall, we only set that 1/4 inch thick, and we set the 0 at the bottom. So that's why our top of feature is set to positive 250 thousandths, that 1/4 inch, and that's because 0 is at the bottom. We only want to cut the thickness of our part, so we can set this depth also to 1/4 inch. And the way that this works is that the system takes wherever the top is and it applies in a negative direction whatever value is defined in the depth field. So in this particular case, since our 0 is at the bottom of our part and our stock goes from that 0 up 250 thousandths, we have the top defined as positive 250 thousandths, and our depth would be 250 thousandths to bring us to 0. So once that is set, we can actually, before we progress on beyond this page, we can actually set the direction of cut at this time. So by clicking on the profile chains and clicking on chain 1, we can see the preview of that chain that the system has defined from our selected geometry. So this little arrow that we see on the geometry is indicating where our start point is. And because we've clicked on that chain, this allows us to now come out to the CAD window, and we can pick different locations to define where we want this to start from. And the arrow is indicating the direction of cut. So the direction of cut is going to be important later when we're setting our compensation direction, whether we want to be on the left or the right. That's going to be relative to your cut direction. So in this case, I'm actually going to set this up here in this back area, and I'm going to change the cut direction by clicking on the other side of the arrow, and that will flip that arrow. We could also select the chain in the list and then use the reverse direction option to reverse the direction of that chain from there. But once we've defined where we want our start point to be and the direction that it's going, we can go ahead and click OK to finalize our geometry selection. Okay, so clicking the next button is going to advance us to the next page where we have our feature parameters. So the feature parameters are going to present us with the options for that top of feature that we saw in our geometry selection, and then our total depth. So we can actually control that here as well. The rapid plane and feed plane is defining what height the machine is going to run at. So our clearance is defaulted to 1 inch, and that was set in the machine setup. And so from that 1 inch, that tool is going to drop down to our rapid plane, which is right now is 200 thousandths above the top of feature. And then from that 200 thousandths, it'll go down to the feed plane, which is set to 100 thousandths above the feature. And then it'll plunge at a feed rate from that feed plane down. So with laser plasma water jet, these values aren't going to be used as refined, I guess, or they're not as important. The clearance plane is really your main thing, and then getting down to the top surface of your part. So this applies more to the router and the milling guys, which will have a completely separate video to cover that. Down here in the lower right, we get to see a preview of the selected geometry that the system is going to work with. All right, so moving on, if I click the next button, it's going to take us to our machining strategy page. So this is where we actually pick what type of machining operation we want to do with what we have picked. And in this particular case, we want to do a profile. And the default strategy for profiling is a rough and a finish pass. So that's 2 passes around a part. For laser plasma water jet customers, you guys aren't going to be as interested in the roughing operation because we really just need to do that 1 pass around a part and call it done. So what I'm going to do is I'm going to select this profile rough and then click the red X button, which is going to delete that roughing operation and simply leave us with just the finish. Now, if I did want to have other machining operations be applied to this geometry, over here on the right-hand side, we do have an available operation list. And by picking one of these and clicking the over arrow, it will apply it to that list on the left. Again, we're only interested in a single pass around this part, so I'm just going to make sure that we have a profile finish, and I'll continue from there. So let's go ahead and click next, and that'll take us to our next page. On this next page, we're presented with tab options. So tabs are bridges of material that keep our part connected to the sheet itself so that it doesn't completely separate and fall away or move. So we have a full range of tabbing options, and some of these options pertain to laser plasma water jet, and some are good for routers or milling machines. So to use tabs, you can simply enable a tab on a chain, and by default we have the number of tabs, and those tabs will be specified in this number of tabs box down here. And the preview will show us where that tab is located. If we use the manual tab option, then we can click on Edit Tabs, which will allow us to go out to the CAD window and actually pick a spot on our part to define where that tab is going to be. So if, for example, I click the middle of that edge and say OK, we can see that the manual tabs, we've got these 2 tabs now on the part, and anywhere that I click, we're going to create, one of those tabs. Now, with laser plasma water jet, when you have a tab, you're typically not going to want to pierce right on your material, so you can apply leads to these tabs, which the system will lead out off of the part using the specified length. And you can also define a radius if you want it to arc off of that workpiece. You also have the ability to turn off the lead out, so that rather than leading out off of the part, you can have it just turn the laser plasma water jet off right where it is on the piece, and then it can reposition to the lead for the lead in. So just know that you have control over those parameters. Now, the width is going to define how wide that tab is on the actual workpiece. And you do also have options for angles, where you can define the ramp angle for a tab. For laser plasma water jet, you are not going to be concerned with those values. So I'm actually going to turn tabs off as we progress through this, and I'm going to go ahead and click Next to look at the next page. So the next page has to do with the post-processor and how the output is going to be generated. So you can define a work offset if you're using a machine that has a specific ability to define work offsets like G54, G55, G56 for part 0 locations on the table of your machine. Then you would select the corresponding value here, 1 being G54, 2 being G55, etc. If you don't have a machine that uses those work offsets, then you don't need to worry about these options. And then the ability for contour ramping output, you don't need to worry about this on a laser plasma water jet style machine. We're not going to be doing any helical type moves, so we're not worried about that one. So we can go ahead and just click Next and pass that page. So this brings us to our tool page. Now, the machine that we picked for this job was a plasma tool. If you picked a laser or a water jet machine, then this page will look slightly different yet similar. The image will update and some of the options will change that you see, that are related to those machines. So the values that you're going to be concerned with are this diameter. So this diameter needs to be the value that, based on the nozzle and configuration of your machine or the focal point, what is your cut width in the actual material. So if you take a cut in this type of material and you measured how wide that cut was, like let's say it's 45 thousandths of an inch for an example, then we would want to set this to 45 thousandths. Because this is going to determine how far the system offsets the cutting path so that your part itself is left at the proper dimensions. Now, depending on your machine and how the post-processor is configured, then you will input the different options that you have. If you can choose between different gas types for your machine, then you'll need to select those. The feed rate, pierce dwell, pulse frequency, power settings, these are all going to be specific to what the requirements are for your machine based on the material that you're cutting. And the post-processor department will have your post-processor configured to operate with what's required for your machine as far as the output goes when you put the values in these fields for the respective material that you're cutting. So it's important to know how your post-processor has been configured so that you can put the appropriate values in here so that that can be output to your program. So looking at the next page, now we're actually getting into the parameters for the machining operation itself. So we've defined the plasma tool, and we can see that from the tool and everything below it over here in the tree, that these are child items under this profile finish operation. And the patterns page is going to define the pattern of how this particular operation is cutting around the part. In this case, the only option that we have right now is the system compensation. So earlier I mentioned that diameter that we were setting on the tool page controls how big that cut is so that the system can shift off of the side. And as I change these options, you can see in our little preview window here, we have graphic examples of what these options are actually doing. So system compensation means that the CAD-CAM software is going to shift the numbers that are output in the NC file to account for the diameter of that cut width, and then that will leave you with the appropriate sized part when it's cut at your machine. Now, machine compensation is going to use functions inside the machine controller itself, where you would have values that you would set in the machine's controller to define how wide that cut is going to be, and then the machine itself will shift over by half of that amount so that you're left with the appropriate sized part. So in machine compensation, the comp will be handled by the machine. In system compensation, the compensation will be handled by the CAD-CAM software, and then the program that's generated will be handling that offset of the profile so that you end up with the part that you need. Now, if you want to literally cut just right on center line of the geometry that you've input into the system, then you can turn both system and machine compensation to off, and the software will output the cut motion right on the center line of what that geometry was that you put in. So we're going to set this to left for this example, and we're going to click next and continue. So on the parameters page, we start to define the parameters for this machining operation, and we have two different group boxes here. We have a finish group and a depth group. Now, the depth group in this particular case for laser plasma water jet isn't really a concern for us, so we're going to ignore that section, and we want to just look at this side allowance box. Now, if you wanted to leave extra material around your profile that doesn't get cut, so let's say that you're going to cut around a shape, but you want to leave extra material that can be ground off afterwards and cleaned up, then you would be able to put that value in the side allowance field. So if I put 200 thousandths, then it's going to leave 200 thousandths all the way around my part in material. So in this example, we're going to leave that set to 0. And the bottom allowance, again, because we're not worried about depth, we can just ignore that field and move on. So clicking next will advance us to our next page, which is the leads page. So on the leads page, we define how we actually lead in and lead out of that profile that we've selected. So the system will default to a vertical lead in, but let's go ahead and just do a blended lead in. So a blended lead in is going to give us a line segment and a radius, and the tool will then cut around the shape. And then when it leads out off of the part, it's going to do this nice sweeping radius and then that line from there. And the length of that line and the size of that radius is definable through these values here. Now we also have options like parallel or right angle, and as you click these options you can get a visual clue as to what these are going to do, but in this case we're just going to use blend and continue. Okay, corner types allows us to define how we want corners handled for external or internal corners. For really what we're doing, we're not going to worry about any of these options right now, but know that we can put radiuses around them. We can make them sharp corners. We can, have the system do loops on the corners, also commonly called as fishtails. Do a triangle type cut and so on. Again, we're just going to leave these to sharp, but you can experiment around with these options and see what they do and see if that's an option that would benefit you. So the next page is this machine sequence page. And remember when we were selecting geometry, we had that one chain. Now, if we had multiple chains that we had defined at the time of selecting geometry, then here we could control the sequencing of how the system is going to process through those chains. The default is closest, and it does work in, quite well in most scenarios. However, you do have different sorting options that you can choose if you so do, if you wish. We're not going to worry about that because we just have one chain. So clicking next takes us to advanced feed rates. So here we can control, if we want to convert rapid moves to feed rates, which in this case we don't want to do. That's typically for high-speed machines that are doing milling and stuff like that. But then the leads, this may be something that you want to be able to change, and that would be if you want to alter the feed rate that is used for a lead in or lead out move, then the percentage that's defined here is the percentage of the feed rate that was defined on that plasma tool page in this case. So from there, we can adjust those individually so that all the leads would have that different value. You could go faster or slower than what you're cutting around the part. All right, so I'm going to go ahead and leave those turned off, and I'm going to hit compute. And compute is going to go ahead and generate our path, and we can see that we now have a path going around the part, and we have basically completed our first machining operation on this particular part. Okay, so there's really only a couple of things left that I want to show in this video. One of them is the backplot function. So over in the CAM tree, if we look at our feature and we expand it so we can see our profile finish operation, if I right click on that profile finish option, I can see in the menu the backplot option in the menu. So I'll go ahead and click on that, and what that's going to do is that's going to show us on the screen. I can step through and see the path going around the part, and I can also, if I restart it from the beginning, there's a speed slider here. I can just hit play and change the speed, and we can see that path run around the part. So that is kind of our backplot. That's a quick and easy way to see kind of the motion of that toolpath. The other is we can launch simulation, where simulation's actually going to take us out into a full, it'll show the whole stock and give us a 3D simulation of what this is going to look like. Cutting out of that piece of material. So here we can see it cutting around, and this just gives us a 3D version of that cut. So, all right, if I want to generate the NC code, that's the program that we're going to run in the machine, then I will come up here to the top and click the Create NC button, which will run the post processor, and over in the posting window, it will display the program. From here, I can simply right click, save as, save this to my thumb drive, or depending on if your machine's connected to your PC, where you can just throw it in a folder and access it from there, or if you need to put it on a thumb drive to take to your machine, you can just do save as and save it to that thumb drive. So that pretty much wraps up this particular part, and there's lots of other features and options that we didn't go into great detail on. But again, I just wanted to give kind of a rough overview of everything and just give you a quick idea of how you go from creating that job to the toolpath and generating the code and so on that you're going to run on your machine. So I hope you found this video helpful, and I look forward to making more videos for you. Thank you.